Whew. Yeah, that's okay. It's not even. I think the quiet hour is 10 o'clock. Alright, one, it's March the 9th. Alright, we have another easy one, which is good. Allowed us to push forward this problem. It was not a. Okay, I remember this one, right? So yesterday we tried two methods. One is to. I mean, two methods is actually the same. It's just two paths. You reverse once, you create it, and then you reverse back. So it's two paths. And today, the first method I'm gonna try is, oh hello, have someone say hello. So today, first one I'm gonna try is recursion, right? We can do this recursion, which means we don't have to do extra space, right? We don't have to do extra space. But I think even if you do recursion, you probably have to. No, I think if we do recursion, it'll be fine. It'll be fine. Yeah, so we do recursion, and the top solution in the forum can do it in one pass. Okay, you can do it in one pass. I tried to think about how to do it last night when I was in bed, and I fell asleep like right away. So I didn't know how to do it in one pass. So probably need a little bit of hint on how to do this in one pass. We're gonna think about it. But this is the first thing to do today. Seems very simple, so we can just plow through this. All right, seriously, I am going to learn Go. All right, we're gonna go Go. I don't think I will go Rust. I think I'll go with Go. I really want to do it. Go is available here, so we can definitely do it, and then code Go a little bit, put it on our resume, make us more employable. All right, intersection of two arrays. Given an array and another array, return an array of their intersection. Each element in the result must be unique, and you may return in any order. Wait, hold a second. Intersection, but everything has to be unique. I see. So we can, I'm pretty sure Java, I can turn this into set and then do the intersection. That's how I would do in Python, right? That's how I would do in Python. And Java, probably you can, I don't know. I mean, we set the numbers all the way to 1000, so we can set something up. Yeah, we can set something up. It's just gonna go through this and go through this. Yep, so we go past the first one, we record which one is in it, and then we go to the second one, and only the one that's in it we'll put into this. We'll put into it. All right, let's do this. It's gonna be 10. Let's copy this. All right, so we then have, what do we call it? We call it, we don't call it counter because we're not going to use it for counting purpose. We just use it for indicator. Let's call it indicator. Okay, indicators. Okay, so it's going to be int this 101. Right, because 1001. So okay, it should be new int do 1001. Right, and for int n of nums1, right, and then we say if indicator n is equal to 0, then we set it to 1. Right, that means it exists. Okay, and then we say the result. The result has to be an array, which means I have to use, I have to use a list first. Right, we have to use a list first. Nope, that's not what we want. Let's do it again. List integer rest list equal to new array list. Okay, and then for int n of nums2, right? And we say if indicator n is equal to 1, right? Then we say rest list dot add n, and we say indicator n, and we reset it to 0. So if we hit it again, it will become 0 again. So we don't have to worry about it. We won't double count it. And as we go through, now we need to turn rest list dot to array. I'm pretty sure we can do to array, right? Return an array containing all the elements. Okay, I think I can do that. And let's see if I return this on the type. Type seems to be good. Yeah, that shall be it. Okay, throw these into it. Oh, what if there's nothing? Oh my goodness. Cannot be convert. Oh my god. Okay, I actually don't remember. I do not remember at all. So it's Java array list to array int, right? That's what we want. Dot stream, what the hell? List dot stream dot map to int dot to array. Jesus. That is just... Yeah, as I read, this is really the thing. Guava. I never use it. I really should. It makes things so much easier. Okay. So which one do you think you want to use? I don't know which one I should use. I want to use this stream thing. So what does this do? Get a stream from list, obtaining int stream by mapping each element to itself. Unboxing. Oh, this is the unboxing thing. So the primitive type gets boxed into this type. So we unbox it to int value. Value hold by each this, done automatically since Java 5, getting an array of int by calling to array. Or you can do call int value on this. Okay, let's try this. Let's use this. Codeforce. Codeforce isn't Codeforce a very difficult one? I think my impression is Codeforce is harder than LeetCode. Yeah, throw it at maybe I have some insights. Wait, hold a second. Did I not copy? Come on. I did Command C and I do Command V. There we go. Then what? I think I screwed up the formatting. Okay, and then it's not list, it's a rest list. And this has to be this. Yeah, this problem is very easy, but we have to do it, you know, I have to keep the stream. But it's not easy in Java because there's always these type of little things, you know, you don't know. There we go. Yeah, you have to use whatever the Java thing to do this. Java is hard, I feel. I was never dedicated to do Java. It was just more of like a necessity. I feel like, yeah, you have to know Java. Okay, this is when. And what do we do? 2 milliseconds. Okay, so this one is done. Okay, so this one's done, and then we're gonna move on to this problem. And we solved it yesterday, so now we're gonna do the other methods. So I have solution 1, and I have solution 2. Dude, I have solution 3. What? I have 3? Oh, solution 1 did not work. Yeah, solution 2, solution... Okay, now we're going to go with solution 4. Okay, so we're going to do solution 4. Let's reset the whole thing, and then we're going to try solution 4. Oh, really? It all started from the pandemic. I got a little bored, so I just started doing this. I'm glad you like it. I mean, it was really nothing. I don't know how much people can get out of it. It was just me talking. Just me talking. All right, so this one will be solution 4. So what we're gonna do is something called recursion. Okay, we're gonna try recursion to solve this problem. It should be too hard. Okay, recursion. How do you recurse it? So double it, right? And well, basically we say, okay, we recurse this, and we want to return a new head, right? We want to return a new head, which points to a new linked list that is double the current value. So I can say, okay, I will call my next, and it will do everything. And what we return is going to be, the head, right, of the remaining, and the carry, right? And then I can do my current one, double it plus the carry. Okay, and then I can do this, and eventually after I'm done, so okay, so I think I know how this one's done. Oh yeah, today was early. Yeah, today was early. I decided to do it a bit early. Yeah, my schedule was all over the place. Really all over the place. All right, let's call it recurse. Let's call it helper. Let's call it helper. So what I need is just a head, which is going to be optional list node as well. Okay, and then what we're going to return, I'm going to return it's going to be a tuple. Okay, it's going to be a tuple of we call it list node. It's actually going to be optional, right? Because it could be empty. So it's going to be optional list node and an integer. Okay. All right. So if not head, what do you do if not head? Then we just return head and 0. Okay. If head. Okay, if head, then what do you do if head? Well, if head, then we say next node and carry shall equal to, we call helper again. All right, helper head dot next. Okay, so we get a next node, which is completed, and we got a carry. So now I'm gonna do myself, right? I'm gonna do myself. So we can say carry and value will equal to div mod, the same thing, node head dot val times 2 plus the carry, and then divide by 10. Right, now once we're done with that, we're going to return we can say new head, right, equal to new list node with value equal to v, right, value equal to v, next equal to next node. Right, now we connect them together, and then we'll return this new head and the carry. Okay, so that's a recursion function. Then we're gonna say new head, right? Actually, we don't call it new head, we call it next node carry equal to helper helper head. All right, I don't like to call this head. Let's call this node. Okay, I'd like to call this node, so we will be not confused. So all the head need to be turned into node. Okay, so the next node, this is also node. Okay, so this will be fine. And we say if C, then we will return list node val equal to carry, and next will equal to next node, right? Next node. Otherwise, if we don't have carry, then we just return next node. All right, so let's test this one. What is my favorite language? I don't have too many. No, I know Python the longest, so I like Python, but Python has its obvious issue. So for small projects, yeah, I do Python. Data processing. I mean, in school, it's almost exclusively Python because there's tons. Because my project is all machine learning stuff related, so it's all Python. And I guess just whatever task I need to do, right? I'll use the language for it. So Python for generic programming is always Python, as long as it's not performance critical. I do Python, and I also do apps, mobile apps. It's JavaScript for sure, and that's pretty much it. Just these two just really sustain me a long time. I mean, I did Scala for a while, and that was very interesting. You know, a little bit dabble a little bit into the functional programming side. Scala is very interesting. Yeah, C++. Oh, I remember the C++ day. I mean, the first language I learned when I learned Python by myself, but in school it was C, right? It was C, which I think is great. And then it's also my first technical book I ever read was in C pointer. It was good memory. C++ is just, yeah, I don't like C++. C++ is way too many features. Way too many features. I am a web development, and every quarter you have a new framework coming out. Come on. No, I mean web development. Here's the thing, like for me right now, if I really want to create some stuff, I think a few tutorial on some framework will just get me on the front end working, and I will deal all the other stuff into some cloud provider. I mean, what's the one that's behind Next.js? Vercel, right? I think I can just do Next.js for front end. I can just do whatever, right? Or those no code platforms. I actually quite like it. No code platform really get the front end experience much easier. I mean, it's limited for sure. Yeah, it's limited because you're basically it's no code. You use their tools. Yeah, there's a website called Retool, Retool. I use it in the past for I just want to get some front end UI up as soon as I can, and I have some backend code. I have some backend already written, some database already ready. So I just need some front end, so somebody else can use it, can just click buttons. So that was a good experience. But front end, yeah, I don't do much front end. Yeah, I mean that's the real money, right? Algorithm, data structure, backend work. Yeah. Now I want to learn Go, really. I touched Go a while back, but it was just for a specific project, for a specific function actually. There's a bug I need to fix, so I have to go inside Go and take a look how it works. But I never really went too down on that path. So I want to do Go, and of course it's very, very popular these days to learn Rust. But I feel like Rust or Go. I more want to do Rust, but I feel like the learning is a little bit too heavy. On like the learning curve is a bit too high for me at the beginnings, and I still consider myself very, very unexperienced. So I will go for Go. Yeah, that's what I want to do for Go. I have a couple of like projects ideas, some CRI, command line stuff I want to do. I think it'll be interesting if I get enough knowledge in both Go and Rust. I can do that in, let's say, like in maybe 4 languages, because I did some CRI in Node.js. So it could be Node.js, Python, Go, and Rust to build those command line project. It'll be very fun to practice all those. Yeah, software architecture. I have no idea of software architecture. These things are too hard. All right, look at this. One pass, no reverse, 8 lines. This is the legend. Okay, how do you do this? Again, okay, I haven't really thought about it yet. Let me think about it. So we try to double this number, but we do it one pass. How do we do it in one pass? Unless you are using stack, right? You basically turn this recursion into a stack. You just like you do a stack yourself. I mean, yeah, if you do that, I can see how you do it. But other than that, how do you do it? One pass. Oh, DevOps. Oh, man, DevOps. My understanding in DevOps is Kubernetes. No, okay. CI/CD. Okay, CI/CD pipeline, right? Some bunch of get the Jenkins to work, and then push to Kubernetes, and then somebody yelling on the channel, "Hey, the Kubernetes, the node is down," and then you're the DevOps, so you just go ahead and okay, I'll fix it. All right, the memory is overflowing. You guys are pushing too many stuff. We have to add we have to add more nodes. And then the CTO come to you. We don't have enough budget to spread out more nodes. That's kind of the DevOps, like, to me. Very, very tough job. And then you really have to know this. Like, I think what Kubernetes has like tons and tons of command line stuff. Man. Yeah, Dockers. Yeah, exactly. Dockers. The Dockers, the Kubernetes, all the pipelines and stuff. It was not easy job. It was not easy job. And it's like mission critical. And you have to be on call, right? If you are like truly DevOps, you have to be on call sometimes. Because if the service is down, you're the one who's responsible to get it back up. I mean, the dev, yeah, it's like dev, QE, and the DevOps. I mean, small companies, you might combine some of those together. I mean, a small company probably don't even have QE. I do have a GitHub account. I was active before, but not anymore. So I have work. So, and I have a few open source projects that's just left hanging. I should really pick up because people are putting issues out, and I wasn't fixing it. No, I'm not saying it's no good job in DevOps. It's just it's a tough job to me. From my understanding, it's a very hard job, and honestly, like I don't even know how can you get an internship in DevOps. That's a good question. I don't know, because to me, from my experience, DevOps is always like more mission critical, right? So like you can have a regular dev as intern and throw some project, and as long as you don't give the intern access to production, your production will be fine. You won't have to worry about anything. The intern can screw up. It doesn't matter. But DevOps side, like how do you train a DevOps? That's a good question. I don't know how you train a DevOps. And do they just normally migrate from a regular dev to DevOps? Yeah, I do think DevOps is a hard job. It's just it's a lot. It's for me. It's just it's a lot of stress. It's a lot of stress. Like for the dev, you have a deadline, but before the deadline hits, every day you just pushing forward. If you got stuck, and then you just got stuck, you take a day off. It's okay, right? You can take a day off, and you just need to pick it back up later on. But a DevOps, like something is down, you really have to get on it, right? If the production is down, yeah, you have to be there to fix whatever problem. If your development instance or your staging instance, yeah, your development instance is down, you have to be there because the dev cannot do any work, and then they'll be just paining you on Slack or whatever channel. And then you'll be like, I could just, I'll do it. You have to fix it. Staging is down. Then if the staging is down, your CEO, your CTO, they cannot do demo to clients, so the sales go down. So you have to fix it. Production is down. Definitely you have to fix it. So like whenever something is down, you have to go fix it, and it's just it's just stress. It's a lot of stress. But on the other hand, if you're really good at your job, you hold a lot of esteem, and I actually don't know how much DevOps earns, but I think they should earn a lot because they are really critical. The DevOps, what's the fancy word for that? SRE, the site reliability engineer. SRE, they earn a lot because they're really the one who make sure everything's working. All right. And let me think, how can we do this in one pass? How do we do it in one pass? I mean, you cannot compute your current without knowing the carry, right? But on the other hand, the carry can only be one. Is that a correct statement? Yeah, the carry can only be one. So you can say if this one will produce a carry. But how do you know this one will produce a carry? Well, if it's a 5, right? If it's a 5, then it will definitely produce a carry. If it's a 4, then it will not produce a carry. Oh my god. Is that a solution? Okay, there's a little bit of mathematics here. So because we multiply by 2, right? The way you produce carry is if it's 5, because 5 times 2 is 10, then you have a carry. But if it's a 4 times 2 is 8. And no matter what, the maximum carry can produce is 1. So if it's a 4, you don't produce a carry at all, even if you have a carry put on you. Which means in this case, right, we have 1, 8, 9. If we go left to right, we're processing 1. 1 is 2, right, times 2. And then you check the next value. The next value is 8, which is guaranteed to produce a carry. So you have to be 3, okay? Then you go on this one, 8. And you double it, which is 16, okay? Then you check the next one is 9, definitely give you a carry. So this one will be 7. Then you check 9. Then it will be 18, right? So you have an 8, but nothing. So the answer is 378. Lord, this might actually work. So 9 is going to be 18. And we know it's a carry. So we can actually put a carry on the outside. We say, okay, a carry is a 1. And then this is 9. We know we have a carry, so it'll be 9. This is again 18. We check the next one. This is going to be 8. And then we have a 1. Oh my god. Yeah, I agree. It's the whole infrastructure. Yeah, the whole infrastructure. Does that include clouds? Right? Does that include cloud? If you push stuff to cloud? Does DevOps have to do with cloud? I guess so. I mean, yeah, I guess like if you manage your own servers, then the DevOps handles that. If you push it to the cloud, the DevOps has to handle the cloud. Yeah, it's a very different knowledge base. It's a very different knowledge base. All right. Anyway, so I think I have an idea for this one path, but it's really, really smart. I'm not sure if I can do it in 8 lines, but let's give it a shot. All right, let's do this. So we call it solution 5. How about that? So this one we do one pass. We leverage the properties that if we doubling a digit, right, even with carry, the max carry it can produce is 1, and the only digit that can produce a carry is from 5 to 9, right? all the other 0 to 4, right? 0 to 4 does not produce carry, even if a carry is pushed onto it. So because of this, right, you can say because of this, we can predict whether the current node will experience carry by checking its next neighbor. All right, so what we're gonna do is Docker. Yeah, doesn't Docker also run cloud themselves? I don't know. Maybe they do. Yeah, this is a whole different knowledge. Kubernetes stuff is just complete different knowledge. Okay, so we're gonna do one pass, right? And what we need to do is so we're gonna have node equal to head, and we're gonna say while node, okay, while node, and I need a dummy. Okay, so dummy equal to a list node. Okay, dummy is that, and we say new node. Okay, new node equal to dummy. So while node, we have the value. We're gonna check the next one, right? We check the next one. So we say the next one, we're predicting if we have a carry, right? So we say if node.next and node.next.val is in between 9 and 5, right? So if it's 5 to this, then we say carry is equal to 1. Otherwise, carry is equal to 0. So carry is equal to 0 initially, right? Carry initially is equal to 0, and then we say if it's this, then carry is equal to 1. We can probably put this in one line, okay? How do we put in one line? We can do this, and we do this, right? And then we do else 0, okay? Okay, so carry either 1 or 0, depending on what the next value is. And then once we do that, we can say the current val, we can do a CV again, shall equal to div mod node.val times 2 plus C and 10. Okay, so we got a value, got a C. But this C is useless because that's pushing to the forward and we don't use this. So we can just do underscore. And then we can say new node, okay, dot next. No, new node, yeah, dot next equal to list node, val equal to v, right? And then node equal to node dot next, and new node equal to new node dot next. Okay, blah, 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 blah. Once we finish this, right, we finish this. Once we finish, we need to check the first node. Then we say if head, if it's 5 smaller equal to head dot val smaller equal to 9, which means we have a carry, then we shall return list node, right? List node val equal to 1, because that's the carry, and next node next shall equal to dummy. Oh, I don't have to. I have a dummy. So all I need to do is we set dummy dot val equal to 1, and I'll return dummy, right? The dummy node. Otherwise I'll return dummy dot next. That's not 8 lines, right? That's 1, 2, 3. We start from 138. That's 12 lines. Okay, let's see. Let's see if this one's right. All right, it's fine. All right, let's see. Are you right? I can throw some other examples, right? Right, give me a shot. It looks all right. Let's give it a shot. I mean, I could just say val equal to 1, just guess, right? I do that, and I say return dummy if this else dummy.next. I can save a few lines. Okay, I save 3 lines. Now it's 19 to 28, 10 lines. 10 lines. It's all right. Try this one. Is right. Yeah. Okay, so now we have a whopping 5 different methods. 5, right? 5 different methods. All right, what is this? Yeah, it's the same. Yeah, we have the same idea. Okay, that's actually good. Oh, he doesn't. Okay, he doesn't create a new one. It's fine. Yeah, it's just. Well, we had the same idea, but we got a little bit direction. Okay, I say okay, only do one pass. I never thought about we can do one pass, so that's something else. Okay, all right, move on. Let's do one more. Let's do one more today. Okay, minimum absolute difference between elements with constraint. You are given a zero-indexed array, okay, and integer x. Find the minimum absolute difference. Minimum absolute difference. Between 2 elements in the array that are at least x indices apart. In other words, find 2 indices ij such that the minimum distance between them is largely equal to x and the absolute value of them is minimized. Return an integer denoting the minimum absolute distance between the 2 that are okay. So in this case we have 2, right? And then 0, 1, 2, 3. We need it to be larger or equal to 2. So these are the same, so that's 0. That's the minimum you can get. In this case, have to be larger than 1. And this 3, 2. Okay. So x can be 0. Huh. What's x is 0? What if x is 0? What do you do? Oh, x is 0, which means anywhere, right? Because it's largely equal to x. Gotcha. X is 3. Ah, I see. So have to be different by 3. 0, 1, 2, 3, right? This is the only option. 1 and 4. Okay. Let's see how do we do this. I mean, x basically, because you have, a0, a1, a2, a3, right? Doesn't really matter how many you have. And then give you an x, basically, it's like a box, right? Like if x is equal to 2, that means the smallest you can get, 0, 1, 2, as smallest is this, but then you can get this can get anything beyond. So if the answer is some value, then it has to be like there. So what if we go through everything, okay, and for each value we record where it occurs, right? Where it occurs. So in this case, 4 occurs at 0, 0, 1, 2, 3, and 3, right? 3 occurs once, just 1, and 2 occurs in 2. So once we've done that, we can, the first check, like the minimum value, we want to get to 0. Okay, 0 is always the minimum. So as we're preparing this, we can actually check. Every time a new one is encountered, we check with the first one to see if the difference is larger or equal to x. If it is, we return 0 immediately. Okay? If it is not, right? If it is not, like in this case. So in this case, 5, we get a 0. Yeah, every one only occurs once, right? 3 is 1, 2 is 2, 10 is 3, and 15 is 4. So every one occurs only once. So there's really nothing. And then what do? And then maybe we sort this, right? We sort this thing. We sort the keys. So key will be 2, 3, 5, 10, 15, right? We sort them. And then after we sort them, the minimum absolute difference must be adjacent, right? Adjacent. So we compare 2 and 3. So we take a look inside. We will grab basically the biggest index of here. So the biggest index of this and the smallest index of this, or the smallest index of this and biggest index of this. Because what we want, no. Scratch that. We want it to be large, okay? So it has to be, no, it's right. So because it's basically a range, right? You have some value and you have a range. You have a low, you have a high. And then you have another one, you have a low, you have a high, right? And what we want is to, because let's say these two are adjacent, okay? So they produce the smallest difference. So what we want is to find one value in P and one value in Q such that their distances, so that distance is the largest. And to do that, we need to pick the smallest here and largest here. Hopefully this is smaller than this, then we get a max, or we pick smallest here and the biggest here, right? So because the range could be like this, right? So there's a low, is a high, there's a low, is a high. So one low, one high, okay? Or it could be, it doesn't really matter. That's just that. So you have to pick a low on one side, a high on the other side, or low on one side, high. So it's a two things. So you do that, and it could be you only have one, but that's okay, right? That's okay. So you do that for this, and you get the value, and you try this, you try all of them, and if it doesn't exist, then it just does not exist. If it exists, it will exist, right? Someone will work, and then just keep track the smallest value. Oh, it might not exist. It might not, right? It might not. Like the 2 and 3, maybe they're too close together, so it doesn't satisfy. And if it does not satisfy, then you don't do it, right? You don't do it. And what we want is to find the minimum absolute distance. So we can set the starting with very high, and then we go through this, then we can get it. Okay, I think this is a solution, right? I think this is a solution. We can definitely do this. Okay. No Java. Let's get back to Python on this one. 2817. Okay, so this one is good. Okay, so we're gonna do 17. LeetCode 17. All right. I'm gonna copy this. All right, let's do this. We need a default dict. So from collections, import default dict, right? And then we're gonna say, what do we call it? We call it indices. Okay, indices equal to default dict of list. Okay, and then we're gonna go through this for I n enumerate nums, okay? And then we say indices and wait, hold 1 second. Hold 1 second. I'm still a little bit confused about 0. Right? What does this do if 0? You can only do with yourself. So I think this is answer should be 0. Yep, answer is 0. That's good. So with this dot append I, right? And then we say if I minus indices 0 is larger or equal to x, then we return 0. Boom, done. Right? That's it. That was good. That's it. So let's say this is oh, hold a second. That's not right. That should be n, right? So we're gonna say for this one, what we're gonna say is the 2 number can be the same. So I have 2 values, right? 2 numbers of the same value is at least x distance apart, right? Otherwise, just keep going, and then once we're done, we're gonna say sorted keys, right? Equal to sorted indices, right? So we get the keys, and then we say rest equal to math.inf, and then actually this is gonna tell me it's wrong, so we're gonna do 10 to the 9th, right? 10 to the 9th. So we can do 10 to the 9th plus 7. Doesn't matter what it is. And then we say for I range len sorted keys minus 1. Okay. And then we say key 1, key 2 is equal to sorted keys I and sorted keys I plus 1. Okay. And then we say if indices key 1 0 minus indices key 2 minus 1, right? Oh, we have to do ABS. Okay, we're gonna do ABS. If this is larger equal to x, or ABS indices k2 0 minus indices k1 minus 1 large equal to x, then we say res equals to minimum res k2 minus k1, right? Otherwise we cannot do it. So blah blah blah. Once we're done, now we return res. Okay, let's go try this out. Alright, is this right? Ooh wee. That ain't right. Oh, we cannot do this. Ah, that is correct. Damn it. Okay, so that's a little bit issue, a little bit trouble here. This is the smallest, but it might not have a value. Good point. All right, we have a problem here. For this, how do we do this? It depends on x, so we might have to do it differently. Let me see. Then it will be maybe we need some different methods. Okay, I think this one does not work. I don't feel like this one working. I mean, the first part is good, right? I think this part is good, but this part leaves a lot to desire. Yeah. Maybe we shall do, I don't know. What do you think? A sliding window? I mean, this method is guaranteed that everything is the smallest, right? But it just so happens that maybe the answer is not in the adjacent. It's very possible that it's not adjacent, right? It's not adjacent. And if it's not adjacent, this method really cannot tell you anything. Interesting. Maybe we can do. Maybe we can do. I don't know. Like a binary search method. Like we set what because it wanted the minimum, right? So I can say, okay, I say the minimum is a certain value, right? And then for the current value, I will add or minus this amount. Whatever is a positive, which is fine. And we add or minus this amount. And what we want to see is if from x and beyond, there is a value at least not smaller than, like, you know what I mean, right? It's like within the range. Okay. So basically now what we want to say is it's a range. We want to find basically the range max and the range minimum. Right? That's what we want to find. The range max and the range minimum. Okay, so here's a new idea, right? Here's a new idea. So we have this again, A0, A1, A2, to A, we call it an minus 1, right? And we have a prefix max. Okay, so it'll be M0, M1 to M n minus 1. And we have a pre-min is a M0, M1 all the way to M n minus 1. Okay, so now we start from n minus 1 and we say my minimum absolute difference is going to be a certain number, because we can do 10 to the 9th, right? We can do 10 to the 9th. So we say like 10 to the 5th, that's the first one. Now we can add this or minus this, whatever. okay? And then we put in here, we just want to say if in the prefix max, so I'm at n minus 1, so n minus 1 minus x, right? N minus 1 minus x is going to be some value. It has to be this one or beyond, right? So like this thing is 3, so 3 minus 3 is 0 from 0. So we want to find a prefix max. Do you contain this value, right? Do you contain this? Do you have a value that's bigger than this, right? That's bigger than, and the prefix max is going to be sorted because it's prefix max, right? It's going to be prefix max because it's just going to be, you know, it won't be non-decreasing, right? Then you just binary search this one, maybe, or you don't even binary search this one. You just check the prefix max of that value, that m this. You check this. If this is larger or equal to this, then it's possible. Then you're already done. And now you're already done. You need to get a smaller one, right? You want to try to find a smaller one, right? Try to find a smaller one, and then try to find a smaller one. Hold on, let me think again, because we want to see this one, the current number either plus, right? If it's plus, then we have to be prefix max, right? Because we need to be bigger than this. But if it's not bigger than this, we can also do minus. If the minus, then we need to be, the prefix need to be smaller than this. Wait, smaller than this? Because what do you want? Right? What do you want? I want to say the minimum absolute difference can be this, right? And if I have something bigger, like if we add this, if I have something bigger, then that means the minimum difference can be even smaller, right? It can be smaller. And if I get something that's smaller, right? If we get something that's, if I minus this, then I can get something smaller, so I can get it even smaller, all right? If we're just saying it is possible, then we just go through every single number, right? We'll go through every single number from right to left. For each one we check, is this possible? Is this possible? Is this possible? And at the end, because every time we also do two, we either do the plus or the minus, right? And then we just go through. As long as one of them is possible, then we can keep decreasing and increasing, decreasing, increasing. Eventually we're going to land at a number which is the only possible way. Okay, we can try that. Yeah, we can try that. So basically delete everything. So I'm gonna try binary search. Okay. Then we need a pre-max, right? We need a prefix max. Oh, hey, you're here again. Yeah, this problem is giving me a little bit of problem, so I have to take. So prefix max, and I need prefix min. So all starts with this. And I say for I in range 1 to, let's call it n equal to line nums. Okay. Dot append max of pre-max minus 1 and nums I, and pre-min, and append minimum pre-min -1 and nums I. Right? Is that right? Because I want is to know we have something smaller to the left. So what's the smallest, right? Okay, in this range, up to I. What's the smallest one? Okay, so I do that. And then I do binary search. I say low shall equal to 0, low high shall equal to, yeah, low is gonna be a 0 because the lowest is 0, highest is 10 to the 9th. Okay, and then we say while low is smaller than high, mid is no low plus high divided by 2, right? And we get a mid. Then we're gonna go through everything. Then we say for I in range from n-1 all the way to the front. Actually, we don't go all the way to the front because we have x, right? We have x. So the smallest I can go to is x, right? The smallest we can go to is x, which means this should be x minus 1. Okay. So for each I know is nums I, and then the other one is going to be I minus x. So what we want to check is, so we can say, what do you say? So it's either the current value, right? So we say the current value is nums I, either this plus mid, right? If that is somebody bigger than you, so we check for the premax. So the premax need to be larger or equal to this, then we can continue, right? That means there's a chance for mid to be even smaller. Is that right? Is that right? Because mid is the difference, right? We want to find the minimum difference. Okay, so what we're saying is I'm adding this if we have a premax that's bigger than this value. Well, bigger than this, isn't that gonna be hold on, what we're saying is there's something bigger than nums I, right? Okay, but we say the difference can be smaller than mid, which means the prefix max, okay, the prefix max must be larger than, well, I mean, it depends, right? It depends on if prefix max is bigger. What if a prefix max is smaller than nums I? What do you do? If prefix max is smaller than, which means nothing is bigger than this, then we should go for the smaller one, right? We should go to the minimum one. Okay. So we say if premax I minus x, okay, if this is larger or equal to nums I, and premax I minus x is smaller or equal to nums I plus mid, that means we are good, then we can break this immediately, right? That just means it's good. Like we can find something that make the absolute difference not bigger than mid, which means there's a chance for the mid to be even smaller, right? For the mid to be smaller. So once that is the case, we can make it smaller, okay? And we can say if pre-min I minus x is smaller or equal to nums I. Okay, I say and pre-min I minus x is larger or equal to nums I minus mid. Right? Minus mid. Now, there's a thing, when you do minus, it has to be larger or equal to 0. If this larger than this, and this has to be larger or equal to 0 as well. Larger or equal to 1. Larger than 0. Right? Because wait, do we have to be? I mean, it doesn't, hold on, does it matter if it's negative value? It matters, right? It matters because if it's something that's bigger than, I'd use add, right? If it's something smaller than nums, I use minus. But if mid is too big, then we basically say we cannot do minus, right? The difference can only be a positive difference. It has to be plus. It cannot be minus. Right? If I'm 5 and I say the difference is 10, when you find somebody who has 10 difference to 5, it's only 15. Right? You cannot do minus 5. That's why it has to be. Okay, actually, this probably, I'm not sure if this is legally okay. So what I'm going to do is do something like this, because I know we can, this is allowed. 0 smaller than this, smaller equal to this. This is allowed, I know, right? So we have something smaller, and then we have something bigger than that, which means we can get a mid even smaller. Okay, so if that is the case, we also break. Otherwise, we just keep going. Okay, so we go through this, we can do an else. This else means we go through all of the value, but nothing works. So mid is too big, right? So no, mid is too small, right? Mid is too small. Mid is too small, right? Hold on, mid is too small, which means if we add something, if mid is really small, and the previous one, it doesn't have anything that's that small. Yeah, because what we're looking for in the pre-max is to find something that's, you know, I'm not sure. You say it's too small. Because given my current value, right, we want to see, given a certain distance, a difference, absolute difference, I can have some other value. All I want to know is if this value exists, right? If this value exists previously, right? That's all I want to know, if it exists previously. So shouldn't you be not doing this? Shouldn't you be checking just the prefix max and prefix min? Both of them? Yeah, maybe you should check both of them instead of doing this convoluted thing. Right? You should check both of them. Because it goes to the extreme. Right? It goes to the extreme. So basically what we want to say is if it's possible to have this amount of difference. Right? I say difference is 1. If I'm a 5, I say difference is 1. Now I get 6. Okay? Now all I want to know is if 6 occurs in the previous. Right? If 6 occurs in the previous. Now, I know that it's basically a range, maybe then we have to do segment tree, right? Yeah, I don't think this is right. I want to know if a value exists in a range. How do I know that? How do I know if a value exists in a range? Oh, I can. I can. I can do a counter. I can absolutely do a counter. No, you cannot do a counter because it has to be from certain point to certain point, right? You need to have an array of counters, an array of n. Oh my god, an array of sets. Okay, an array of sets. So it tells you up into, so we can call this, you can call it dp, right? You can call it whatever. It's that up into a certain index, what are the values existing in that? Okay, yeah, you can do that. Like what exists in that, and then you just check in that set and see if your desired value is in it, right? If it does not exist in it, then that just means from you it doesn't work. So you check the previous one, check up until you cannot check anymore, and then okay. So can we an array of sets? I think it works. Okay, an array of sets, it works. But can we do better than an array of sets? All I want to know is, and again, it's not just one value, right? It's does it exist a value bigger than the one I want, right? In this case, is does it exist a value smaller than what I want, like bigger than me, but smaller than this. Like we have a range. I just want to know if that value exists, right, in this range. Huh. If that value exists in this range. Interesting. What type of data structure do we need? All right, I gotta think about it. I think it's past 1 hour. I need to think about it. I feel like maybe I'm thinking too. Maybe I'm on the wrong path for this one. Maybe there's an easier way. I'm gonna keep thinking about this. This is a binary search method, so I'll keep thinking about this. And hopefully I can get some better idea tomorrow. All right, that'll be it. That'll be it for today. We just did some easy one today. I didn't really get onto this one. All right, we'll do this tomorrow. All right, see you guys tomorrow. Adios.